look at the addition and double angle formulas. Here are the addition formulas, and they're going to be given to you in your formula book. So you don't need to memorize them, just know how to use them. Here are the double angle formulas, which are not given. So you're going to either need to learn these off by heart or learn how to derive them. I'm going to show you how to derive a couple of them as an example. So using the cos addition formula from the previous page, you can derive a formula for cos 2a. The way you do that is by just saying that cos 2a is the same as cos a plus a. Then I can just use the formula. So if I replace b with a in that formula, I get cos a minus sin a. Worth noting there that if you're adding, the formula says you should subtract here and vice versa. This is the same as cos squared a minus sin squared a. So now we've derived this formula. From here, you can choose to replace either the cos squared a or the sin squared a with another identity. For example, here, I could replace the cos squared a with 1 minus sin squared a. And if I do that, I get cos 2a is the same as 1 minus 2 sin squared a. Now we've derived this formula. Those are just a couple of examples, but the other formulas can be derived in a really similar way. Now let's look at some examples. Example 1, solve for x between 0 and 360. This equation, give your answers to 1 dp. Now looking at this equation, it looks suspiciously like sine 2x equals 2 sin x cos x. If you didn't see that straight away, that's fine. With more practice, you will. In fact, 8 sin x cos x can just be written as 4 brackets 2 sin x cos x equals 3. That means we've got 4 lots of sine 2x equal to 3. Rearrange this, we get sine 2x is 3/4. And we can solve this for 2x. Now the initial value that comes out of the calculator when you do that, inverse sine 3/4 is 48.59, but we need to find the rest. Be careful here because we've got 2x. We do need to change the range of x values up here. 2x will be between 0 and 720. So when you are drawing your sketch or doing your cast diagram, whichever way you prefer, you need to make sure that you look all the way to 720. I'm going to do a sketch. Here's 0, here's 360, here's 720. I'll draw a line across roughly at 3/4 and I'll see that there are 4 solutions that I'm interested in. That one has got to be our 48.59, and then the others I can work out. So using the symmetry of the graph, that's 131.41, 408.59, 491.41. To get the final answers, we'll need to divide all of those by 2 and round to 1 dp whilst we're here. So 24.3, 65.7, 204.3, 245.7. All of those are within the original range required. Example 2, prove the identity. I'm going to start with the left-hand side because it looks like there is more to do there. And I'm going to replace the cos 2x with something. I have 3 options for cos 2x. And sometimes you just need to try one and see where it goes. But in this case, I am going to use that first identity there. Because when I do this, I get cos squared x minus sin squared x on the top. That, in fact, is now difference of 2 squares. So I still have cos x plus sin x on the bottom, but I can then factorize the top into 2 brackets, difference of 2 squares. Cos x plus sin x, cos x minus sin x. Now I can cancel that first bracket with the denominator and be left with just cos x minus sin x, which is the right-hand side as required. And we're done. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.